6 times 5, which is 13. So I times R. Now, I started with 24 volts. I'll change colors on you guys. Right, I have 24 volts. When I went across this resistor, I lost 13 volts. Resistors cause voltage drops. They dissipate energy. So now if I had 24 and I lost 13, I'm left with 11 volts. So these, I have to lose 11 volts from there to there. Now, do each one of these get 5.5 volts? No, because each one of those resistors that's in parallel provides a path. And over the entire path, you have to use all the voltage. So I need to drop 11 volts on this path and on this path. And so I can get I2 by taking V2 over R2, which would be 11 over 8. If you had a better physics teacher, he would pick rounder numbers, so we wouldn't have to be dealing with all of this. I got 1.4. And there's two ways to look at this. The current needs to be conserved. So that means that if I started with 2.6 and 1.4 went the one way, that means that 1.2 has to go the other way, because these two numbers together have to equal that. Or I could do that I3, as I write V, I3 is going to be equal to V3 over R3. And this is 11 volts over 10 ohms, or 1.1 amperes. So why aren't these exactly the same? Well, rounding. That's why I said if you had a better teacher, he would have made it so you didn't have to round and they would work out better. I rounded here to 9.4 and I rounded there to 2.6. And so that makes it, it's not a huge difference though between what, if we're talking about 1.2 and 1.1 amperes, is not that big. All right, so series. They share a path. Current. Parallel.